Yeah, so I'll start. You can see my screen too, right? It should say the Reason plus TypeScript with genType. So real quick about why the background for this talk. My name is Kyrylo. I work at a company in Gothenburg called Antura. So we have quite a large code base. The backend we have in C#, and we started experimenting with functional programming a few years back, maybe like 3 or 4 years back actually. So we got quite a bit of F# now, and it's established itself, at least on the backend side. In case not everyone knows, F# is basically like the .NET version of OCaml, you could say. It's really similar syntactically to OCaml, and there's a bunch of differences when you dig deeper. But if you've done OCaml, it's going to be really familiar. And on the front end, our stack is actually React plus TypeScript at the moment. But yet again, since we're trying to experiment with functional programming and add more functional programming languages and concepts to our code base, we've actually tried some other alternatives such as Elm, Reason, and a bit of Fable. Fable is F# to JavaScript. With varied degrees of success, I'd say. And this whole idea that there's something out there that's better than the mainstream conventional way of doing stuff, which today is sort of JavaScript for the most part, is something that's kind of close to my heart, you could say, because I struggled quite a bit when it comes to trying to introduce new technologies or new languages into large existing code bases. So, for example, we tried Elm on a completely separate side project. It was not part of the main code base, and at the time we decided not to continue with it. And the same thing with Fable, basically. So Reason was actually a bit different, but there is still this problem. Like, imagine even in a world where suddenly a perfect world, or a world that's close to perfect, where people just figured out that raw, pure, untyped JavaScript should be forbidden, or at least just stop using it, and figure out that we should do some more robust coding. All the existing stuff would not just disappear. I mean, we still have tons of code written in JavaScript. So at Antura, one thing we have to do when we introduce new stuff, while it's encouraged, we need to make sure that it works well with existing stuff. And with React and TypeScript, it means that we might have some TypeScript components already written, and then it's kind of tricky. You have to use them from Reason. You can do bindings, or we could just start by writing some new Reason components or pure functions and using them from TypeScript. So one of the reasons I wanted to show this stuff today is it might not be obvious, and this is something I discovered myself, how easy and fast it is to actually just start writing code in Reason in an existing TypeScript code base. So basically, it takes maybe like 2 minutes if you know what you're doing, and you can just write Reason code and consume it from TypeScript. So I'm going to do this sort of slowly, hopefully. I'm going to do this in 3 steps. Step 0 is not really a step. Just show that we got an existing TypeScript code base, which is just pretty much create React app, boilerplate. And all I did was I removed the log and tests and the usual stuff that people remove when they start with this. I added 2 CSS blocks, border 3px solid red and blue. That's the pinnacle of my CSS knowledge, I guess. So I'll have to live with that. And that's where we're going to start. So let's go to step 1. Just quickly show some code here. So the main app is largely unchanged. I added this sample component that I'm going to use for the demo, which I call TS component, which is the TS div. That's why the beautiful blue border. It just takes 2 props, a string and a number. It calls this function stringify number that converts the string to a word representation. So for 0, it shows 0, for 1, it shows 1, for 2, it shows 2, and for the full case, the number is too large, which is actually a bug now that I realize it could be negative also. And that's it. So what does it take to write this function in Reason and use it from TypeScript? First thing I would do is I would just grab the docs. And here we have actually those are the wrong docs. It's actually a fun thing with Reason. You never know which docs to look at. Buckle script Reason or Reason React. I actually have a special section adding Reason to an existing React.js project. I'm gonna do both, but if we were not using React, then we wouldn't actually have to do this for now. But we're gonna install BS Platform and Reason React. Let me stop this. On that, and meanwhile we can follow the other steps. So I need to create a file called bsconfig.json and paste all that in. And in the package JSON, we'll need only this script for this demo, the watch script. So we'll grab this. So for now, nothing's changed. Everything still works. What we're going to do is we're going to run the script we added. Watch. And we're going to start by adding a reason file. So I'll call it string functions. And we're going to pull this one in. So the syntax is a bit different, as people who've done Reason probably know, but a lot of stuff we can actually use. Nonsense. Fix the bug. So that's the first place we can just stop and analyze what's happening. So we've created this function in Reason. Here we can see suddenly a small JavaScript file has appeared. And as we're compiling in the background, the BS compiler, buckle script, is picking up all the Reason and I guess OCaml files inside our project and compiling them to JavaScript on the fly. So what happens here is I have a piece of code that's pretty similar to what we actually written by hand in TypeScript, which changes as soon as we change our Reason code. Yet again, just to make a point out of it, we haven't been using genType yet. So this is all the buckle script compiler. We're compiling Reason to JavaScript. So now we don't have this, but we can just pull it in. And yeah, now we're calling Reason code from TypeScript, or I would say JavaScript. I'll explain why in a sec. But a few things worth noting here. The usual workflow that we use during front-end development with live update and everything, this does not actually change. We can modify a Reason function now, and we get automatic recompilation and reload in the browser. Same as we would if we're doing pure JavaScript to TypeScript. So in a matter of a couple of minutes, we went from a pure TypeScript code base to a TypeScript code base that's where we're writing code in Reason. The problem here, however, is that you can probably hover over it. Yeah, you can see that the type is any, so we can still make some silly mistakes. We can write a string here, and this will not give us an indication of the fact that we did something wrong. It will just behave, in this case, incorrectly in runtime. Yes, we can even get pass a parameter or pass something else. Which is pretty silly because both Reason and TypeScript are like two strongly typed worlds, and we have a strongly typed function in Reason, and we have strongly typed functions in TypeScript, but somewhere on the border in between, the type information gets lost, and we're kind of back in JavaScript land with the JavaScript related problems. So let's go back to the browser. That's why I call step one, call a function written Reason from JavaScript. If you had a JavaScript code base, then you could do this without much difference. But step two is actually where genType comes in. So let's go back here. Prepare this link. So again, the same situation as with adding buckle script, adding genType, I guess it's even faster. So I can just grab this one, stop everything, and install. While it's installing, we can grab genType config here. And as to language, since I'm using TypeScript, I can write TypeScript. I'm going to rerun the background watcher and the TypeScript watcher, Babel watcher. And the first thing that we notice is that nothing changed. we still get a reason file, and we still got our BS.js file. In order to get TypeScript to kick in, I have to write type here. And immediately we can see that we got a third file, which is called stringfunctions.gen.tsx. Basically what it does, it re-exports our stringify number function, but adds types on top of it. So it parsed the reason code, it figured out what types we have, and now we've got annotations. So to use it here, we have two choices now. Got the old one with .bs suffix or ending, and we get the new one, which is .gen. So as soon as we pull in the .gen, suddenly we cannot do any stupid stuff. We're gonna get TypeScript warnings. If we pass a number, then it works. So yet again, we can continue working with our standard way of working. We can change stuff and see updates on the fly. Nothing changed, again, in a matter of now probably like 15 minutes, gone from a pure TypeScript code base to a code base where we can write functions in Reason and consume them from TypeScript. And, which is most important, keep the type information across boundaries. So the last thing I wanted to show in the demo, and if anyone has questions, feel free to throw in.
I have a question regarding the types. Is it possible to export something? Can genType be smart and convert something like an option type from Reason to a variant in TypeScript? Is it possible to have that kind of type safety?
Yeah, no, I don't remember. I think they changed a lot in BuckleScript itself as to how options, now I think it's undefined. But we can actually, after this last step, I think we can actually just play around a bit and see how it converts union types, options, stuff like that. If that's fine.
Yeah, great, thanks.
So step three has to, that's like the only React specific step in this like really small beginner like tutorial. The previous steps, you could use them with like a Vue application, you could use them with a pure JavaScript application, jQuery application, maybe Angular application, who knows. There's nothing about it that's React specific, except for this step that's coming next, because Reason integrates especially well with React due to Reason React, and due to the fact that you can write Reason components or React components in Reason. So of course, genType helps with this too. So I think I have everything installed, right? Because we installed Reason React in step 1. So as advertised with JavaScript to React conversion, you just rename the file. In this case, it's not that simple. I'll start by renaming the file, but I have to do a bit more than that. One thing we'll have to do is actually remove a lot of code. So we'll call this make because that's the convention. I'll call it React component. And we're gonna pass let. This nonsense we can remove, no return. This is gonna be called reason div because we want the beautiful red border. Yeah, so we're actually gonna pull stringified number from. So, well, for starters, that's like half the code, 9 lines compared to 19, which is nice. Let's also pull this in here. So, because I haven't annotated this with genType, we have only this intermediate BSJS, and the convention for reason components or reason React components is to call them make. I don't think it's possible to follow the React convention with uppercase anyway, so it's going to be exported as this ugly make, which makes it a bit tricky to import. And we still don't have type safety here. And this compiles, but it sort of behaves incorrectly in runtime. So same thing, like genType or genType to the rescue. All we have to do is to add the annotation. We can also rename it to reason component on the fly, so we don't have to make the ugly import. So we got this name. And let's remove this. Get some IntelliSense help and save this. And we got both in here. Let's just make sure we can't do anything silly. We can't. It will tell us that string is an assignment number. So to here. So that's pretty much it. And again, reload on the fly. When you change reason stuff and change TypeScript stuff, it doesn't matter. I probably should have touched a bit on this. The reason why it works is BuckleScript picks up raw reason files and compiles them into JavaScript and TypeScript with genType. So the TypeScript compiler runs after because it just sees the JS and TSX files itself. So it doesn't actually know that we have reason files. It just sees that, okay, we have a BSJS file and it changes. So Bobil or whatever you're using kind of picks it up on the fly and compiles it as usual. And because because BuckleScript is so fast, we barely get any overhead for compiling the reason stuff first. This is actually a huge advantage because if BuckleScript was as slow as TypeScript itself, then we would have doubled the build times or the reload times. But since it's so fast, it's just barely noticeable. So yeah, before we play around a bit, I thought I'd talk a bit about the adoption strategies. Actually, there is this this article that was written in 2018. That's almost 2 years ago, about kind of same issues that I have encountered myself when introducing new languages or technologies. And there's some like information about how no-red ink switched to Elm and such. Basically, the way I see it, there are two ways to go about it. Either kind of go all in into a new technology if you really believe in it, and either like rewrite existing stuff, but more often you just, okay, we start writing new stuff with this technology. And if we have to modify the old stuff, then we just rewrite it on the fly. And option two is this incremental adoption. So going all in is often frowned upon because it's usually associated with huge risks. in different ways. It costs money. If it doesn't pan out, you have to back up. It costs more money, so you lose time, and people sometimes, or organizations sometimes, do not want to take those risks, while the approach we have sort of allows us to not take huge risks but still try to innovate, and it involves like gradual adoption or incremental adoption. That was the title of the talk. So if we're talking React, it's usually you have a component tree, and you usually would start from the leaves. So you would want, the same way as we had in the demo, to have Reason components consumed from TypeScript components and have the types defined in Reason. And it doesn't have to be just components. It could as well be functions. So if it is a component or a function that only depends, a TypeScript component that only depends on Reason components, then you can convert the parent, and you can go on and convert the whole branch into Reason. Now, this is a great way to try a new language and kind of really feel the advantages and disadvantages and figure out whether it's something you want to continue using. If not, then you can back up. But hopefully, if you go forward with it, you discover some problems and some solutions, and you figure out how to solve them, and you get a better feeling whether this is a viable option. So hopefully at that time you can make a decision, and at the same time it's not too late because you can roll it back. But hopefully if you make a decision to go forward with it, then you can continue converting leaf nodes and branches, etc. And eventually, again, hopefully you end up with a tree that is mostly red, and you have this blue part that is TypeScript stuff that maybe you don't want to touch, but at some point decide to rewrite, and the whole thing becomes red. In fact, only at this point, when you convert the root node to Reason, and you can really get rid of Babel and TypeScript stuff, you get the full advantage of BuckleScript's lightning speed, because as long as the root is bootstrapped with TypeScript, you still have to double compile it. But at this point, if the whole tree is red, then you get even more advantages. So that's one way. Another approach, I actually wrote a bunch of articles about it. It was also a while back. It was more than a year ago. In this case, adding Reason to a view application. I was just sort of playing around a bit, and again wanted to make a point that this isn't something React specific. Reason can be used as a replacement for JavaScript, not necessarily for React. In this case, I have an example where we're calling the API and decoding the response in Reason with BS Access and BS JSON. So yet again, this is possible. Define your types in Reason, call the API. This is not the leaf of a component tree, but it's also in a way the edge of the system, because it's just the other side, because it's also code that does not call any other code, like Reason code that does not call TypeScript code. So similar idea. So good use case is basically everything Reason is good at, and Reason is great at domain modeling with ADTs, pattern matching. State machines is one example. If you've tuned in for last meetup, Margarita was talking about modeling state machines. So if you have a powerful language, you might not need an extra framework such as XState for simpler cases. You could just use ADTs and the powerful pattern matching of Reason. That's an example, some real code I had in TypeScript. I think this was Redux. A lot of action creators. The exact same code, the exact same functionality can be written in Reason in this little compact bit. much easier to overview and much less boilerplate. So this we've showed at the React meetup, for example, a great advantage of the type system. One thing that I have run into that maybe shouldn't be necessarily avoided, but I had trouble with it myself. We have a React component that calls reason component, just like in the demo. That's all fine, but then maybe it turns out that we've got a component library in TypeScript. So that reason component needs to pull in a TypeScript component. Now, for the record, I think there is a way to pull in stuff from TypeScript into Reason also via genType, but I never got it to work. So you can always write bindings, but what I've discovered was that it became quite a large overhead, or it resulted in quite a bit of overhead, because especially if you have another reason component that you want to pull in from TypeScript that maybe depends on another TypeScript component, there's a lot of friction on the edges. So that's something I like to call a reason TypeScript sandwich, or on the backend side, it's C#, F#, C# sandwich, which also results in quite a lot of friction during the edges. So what happened was I kind of started losing track of where the types are defined and are they converted correctly and stuff like that. So it helps when you have a single source of truth, and Reason is really good at modeling stuff. So if types get defined in Reason and consumed from TypeScript, that's kind of a one-way street that avoids confusion like that. So this I would caution against myself. But if someone has better experiences with this, please feel free to let me know. That was all I had. Yeah, you can find me on Twitter or GitHub. That's my name. We can. I can take Pontus' question first, actually, but if anyone else has questions, then feel free to ask also.
Question, but we can take it after Pontus, maybe.
Yeah. So let's see if what happens if we have an option type here.
Yeah. So the question was, what happens if we return an option type? How is that handled by genType? Is it possible? It should be possible, because we can define I think TypeScript calls some discriminated unions with the variants in TypeScript.
Yeah. Let's see. So the option. I just have to warn everyone that first of all, I haven't done Reason itself for like half a year, and second, I've been doing a lot of F#. So my Reason is super rusty now. How do you sum of 0? Yeah, is that correct?
Because the default branch is none, something like that, like the error branch could be represented as a none instead.
Yeah, my Reason syntax. When I was preparing this stuff, I was writing match every time and wondering why it doesn't work. And we're consuming this here. Yeah.
We could check the compiled JavaScript to see what or the genType compiled genType, right?
Yeah. So here we can actually see that it generates string or null or undefined.
Oh, okay.
Then here we can see in the genType. Oh, sorry, that's the wrong one. Yeah, so null undefined or string. And that makes sense. I guess BuckleScript itself, I suppose that's undefined, yeah. My JavaScript is even rustier than my Reason. Then for use cases we have, yeah, here it doesn't work, of course. We need to option map or something. But this is, yeah, this is nothing genType specific. So for discriminated unions, it's actually even more interesting. I think, for example, one thing we could do is we could use a reducer written in Reason. We could model the types, we could model the actions, and we could write the reducer function in Reason and consume it from TypeScript. I think that would be a bit weird, but we can just see what happens. So let's say we have page state or something. The usual stuff of loading and error.
Just to be clear, when I talked about discriminated unions, so a discriminated union in TypeScript is kind of when you create an object and all the possible object types shares a field. You could call it type or discriminator or whatever, and it has a string that defines it. And then you have another field that's the value. If you Google like advanced types for TypeScript, there's a good article there in the standard documentation. So, and that's because TypeScript has something called union types. So union type is, we can't really do this, what do you call it, natively in Reason. When we just say that something is, so a type is this string or this string. We'd actually have to use the string constructor in Reason to say this type is actually a string of the string value or string of the string value to be able to create a type. But in TypeScript we have union types. So we have the I guess they call it simper thing. But we can use that in TypeScript to create a discriminated union, as they call it. And that's the discriminated union in TypeScript will map to this variant, which Reason calls it.
Yep, it's exactly this ugly stuff I've showed. This is the TypeScript, or yeah, we don't have the types themselves, but all of those will become the strings and those TypeScript types.
So in Reason, the actual values start loading or not asked, or that's the actual discriminator. Whereas in TypeScript, we'd have to use an object with a common field used between the types.
Yeah. So let's say we have this page state, page action, page reducer. Here, nothing useful gets generated. All right. I need to. I think it's enough to say that this one should get generated TypeScript because it sort of pulls the rest with it. Yeah, that's pretty much a TypeScript discriminated union. I thought it would generate tags for every case, but I guess the single case, that's called single case, just gets a string.
Yeah, that's a bit weird. I don't know. Like the last time I used discriminated unions in this case as well, as a reducer or action types, I would have done a tag, an object with a tag field for every object there in the type. So then we can basically just switch on the tag property, and then we can actually, you can actually get like proper exhaustive check of the type in TypeScript as well.
I'm pretty sure you're gonna get it anyway. So if we were to use the reducer here, you just pass in the reducer, yeah. So we need to import it. So, and yeah, so initial state would be not asked. Yeah, so you can't do anything that's not allowed, of course. And then state is of type, right? So if we were to switch on state, yeah, so you get auto completion and everything. Okay, so what's weird about it is, what you're saying is you would probably want to match on state.tag. That's true.
Yeah, exactly. So even the variants without the actual data, you could just match on the tag, and then you can have a default case, which does something like assert never. So the return value would be assert never, and then you'll actually get exhaustiveness checking in TypeScript as well.
State tag. If we were to match on loading and not asked.
Yeah, exactly. So tag is pretty much an implementation detail.
Yeah, so now we can actually get the tag out. I guess we need to nested switch in this case.
But it's kind of like, so I pretty much grew up on Redux. I'm not grew up, but I'm not that young. But it kind of maps to that case very good because you always have a action type in your action. So then it's pretty easy to match on the action type itself. So then you know that every if you follow this thing called like the Flux standard actions, basically says that every action dispatch should be an object with a property called action, and then there's a string value.
Yeah,
I guess match on that.
Yeah, so that's true. I mean, if you were to use this one here, you would have to do nested matches. I mean, of course, it figures it out at the end. If the tag is failure, then this is a string. If it's success, then it would be an int.
But I mean, I guess there's other cases where the pretty much not optimized for like exhaustiveness checking and those things. I haven't used genType myself, so it's just a question that I thought about.
Yeah. So for the rest, it does generate. I mean, you do get auto completion and everything. So you can dispatch either start loading or tag loading success, loading failure, and then you would have to provide a value of the correct type. Yeah. So it sort of works, but maybe not the prettiest of results here.
We have a question in chat that says, so BucketScript generates JavaScript, and genType uses this JavaScript to generate types for TSX. Yep. And I believe does genType use this JavaScript to generate types, or does genType use the actual reason code to generate the TypeScript types?
So yeah, I'm the wrong person to ask this. As far as I understand, and I guess Cristiano can correct me. As far as I understand, it uses reason to generate an abstract syntax tree that's used to generate TypeScript types. Whether it uses the JavaScript in between, I'm not actually sure. It definitely does pull it in and re-export it.
So basically, we're using two tools right now, and we have two files produced from those tools. We have genType, which produces the TypeScript type definition, and then we have BucketScript, which compiles the reason to the JavaScript. And those are two separate things, right? Yeah,
it's like 2 steps or 2 extra steps, which are pretty fast. One thing that's interesting, if you're using VS Code, I think that's the Reason language server that does it. It would compile this stuff on the fly without actually running this in the background. Let's just remove this, I suppose. Yeah, I need to get back into working state first. But strictly speaking, in VS Code with Reason language server, you don't have to run this part. I still like to run it because sometimes the Reason language server flips out, and then I'm not sure whether it's my code that's wrong or whether I should restart Reason language server. But with VS Code, I can change stuff here and just wait a bit, or maybe I played around with it yesterday. Yeah, there we go. It's a bit slower also, but yeah, normally that's the way you do this. You have a process in the background that does the pre-processing.
And I guess you could, for like your project, let's mash everything into Webpack or something, so you just start one process and everything's sorted. But I guess this seems simpler. I don't know.
I think there was some issue with that because both are watchers, but maybe it's possible. Not
I think
sure.
It's generally like discouraged to bake BucketScript into Webpack. Okay, I think so. So I have a question if nobody else has a question for me. So you've used this at Antura, I believe.
Yep.
How's your general experience been integrating, doing this exactly? David Sancho has a related question as well, which is how far did you manage to use genType to share types between Reason and TypeScript? Oh, and okay, sorry, it's kind of a different question. We'll start with that one maybe. So he says he tried to share TypeScript records. So I guess how far in the type systems have you gone trying to share things between them?
Not extremely far, I would not say. So we have, I think, if you want to know in more detail, you can check with Margarita on Twitter later. I think she did a lot of work lately. We have one sub project that's bootstrapped with TypeScript. It's primarily written in Reason. So we don't do a lot of interop. I think it's just the index file that pulls in an app.re. So you just need to type the props. I know that we had trouble with trying to have both types in TypeScript and some types in Reason and then pass them to and fro. So that has been a problem. And I think what happened lately was we just kind of revisited this stuff with genType, and we discovered that it works just so much better than it worked a year and a half ago. So hopefully we'll just make another try, but I won't be surprised if we have some loose functions here and there that had the sort of complex logic with pattern matching and state machine-ish stuff that we just have in Reason and pull into TypeScript, not even React components. But the answer is not extremely far. It's a huge code base, and stuff goes a bit slowish usually, unfortunately.
I see. But your experience has been good, I take it then, using genType, or okay-ish?
I would say okay-ish at the time. So that was maybe again a year and a half ago. One thing that I kind of backed out of at the time, the backstory is we have API tests in F# for our APIs. Those are real integration tests that call APIs, get results, call APIs with other stuff, or the results of the previous calls. And my genius idea was just to port this stuff to OCaml, because F# and OCaml have similar syntax, and compile it with bucklescript to JavaScript that would actually do the calls. And I spent some time on investigating that and trying it out. It did not work as expected at all. The idea was it's just a bit of a syntax tweak. In reality, it was for a bunch of different reasons really, really hard to do this. And one of the ideas there was to use this data calling library or part of the code base, both in the tests and in TypeScript code, like in the Vue.js article, that we would have a data calling layer that would be well tested by API tests, and that would also be used in TypeScript with strong type guarantees. But that we basically backed out of, and I think I wrote those tests in TypeScript eventually, just because, well, one of the things, it wasn't possible to do multiple assertions in an easy way, and there is no async await-ish syntax, or there was none in OCaml at the time, at least, which is a huge advantage of F#, actually. Async await-ish, the monadic bind computational expression syntax helps just incredibly when you do asynchronous operations or error handling and such. So this didn't work with OCaml at the time. So that was the negative experience. The rest was sort of okay. I would prefer writing more Reason, to be honest, but it is what it is at the time.
Cool. Any other questions? want to host a YouTube stream?
Let's see. No, it looks, or the stream is alive and well, but there's no questions.
Cool, cool.
There is a beautiful talk so far.
Nice.
Comments.
So yeah, just to wrap up, I'm really looking forward to the next talk, and I was actually looking forward to it for like a month. And this is what I'm gonna do. If someone's using Hasura, you would recognize this UI. I'm gonna go here, I'm gonna click on this button, and I'm gonna try and write some Reason Relay code. So looking forward to the next talk.
So hope it's not a massive disappointment then.
I'm sure it won't be. Yeah, but thanks for having me.
Yeah, thanks for presenting. Great
Excellent.
talk.
It's so I get the feeling we're pretty spoiled in recent time that we have genType. And also I know this guy called Jonathan, I'm not sure if he's watching this, but he's working on a kind of compiler that can take TypeScript and generate bindings for a lot of different cases. Which is also looking really cool. So we have a lot of really good things coming here with Interop.
Yeah.
Should we take another like 5-minute break for drinks and restroom or whatever?